What I want to do is make a simple animated abstraction that would fill the screen, and then I'm going to render this. And then I'm going to test it with a VR headset to see what it's going to be like to be immersed in this space. All right, and I've got some tricks to do this, and I'm charging the VR headset in there, and then we'll render it on the laptop, or we'll render it here. The thing is, you got to use Eevee. You got to use cycles. You can't use Eevee for this. Eevee can't, at least not yet, can't do panoramic rendering. And so, if you're going to render for something that's immersive, it has to be very high resolution. So we're going to do a couple tricks to make something render fast, but still be in very high resolution. All right, and you can get us like banned off of Sheepit if you don't set up these kind of settings correctly. So the first thing I want to do, before I do anything else, is, I don't want to delete the camera. I'll delete the cube, I'll delete the light, and then let's come over to our shading tab. And you can see in our shading tab, when we look around in the view, we have this sort of blurry world, right? What is that blurry world exactly? It's this HDRI, and you've got different HDRIs that you can choose from. And you can turn down the blur, and you can see that it's just a low resolution picture of a dog. All right, and yeah, this ships with every time you download Blender. A bunch of these HDRIs are in here, so you can come over here and you can see this ocean world or whatever that you can look at, and they're low resolution, and that's because they wrap all the way around you, and they're inside of Blender, but you can use these to test your materials and how they look, and I can feel my throat starting to seize up here, so this is going to be fun.
What happened?
I do not know. I'll get some water.
I hate that when you talk so much and then your voice talks. Wait, can you say it?
It's because it's springtime and all the flowers are out, the birds are singing, and the pollen is everywhere, right? I keep trying to make it manifest. All right.
Yeah.
All right. So this is to test our scenes, but if we actually want to see what's going to render, we switch to the rendered view. And this is what we have right now, a gray world, as opposed to outside, which is blue and sunny and beautiful. Okay? So if I were to change that world to something else, that would be wrapped around us. So let's go ahead and do that. So if we're in the shading tab here, we've got the shader editor here. I don't need all this stuff, so I'll just combine it. This is a file browser, so you can drag textures and pull them directly into your shader editor. That's what that's supposed to be for. Let's join that to the left. Let's join this to the left. Now, I'm going to change it from object shading to world shading. All right, and then when I change the world to all white, you can see it's all white. And if I change the world strength, that's sort of the power of the world here. So I'm just going to keep it at 1. Now, if I add a texture to this, so like let's just add a noise texture. I plug up the factor to the color. What we'll see is that noise texture wrapped all around the camera in 3D space. If I choose the color version of that, I get this, which is noisy color, or color noise. All right, and it just wraps around this world in 3-dimensional space. If I'm rendering just the world with no objects in this scene, and I render this with cycles, I render that with the GPU, and I render it, like if I wanted to just render this one frame, I go to render image. We'll see that it's processing it, and it's like, oh, okay, it's on sample 20 of 4096, right? But it already looks fine. So what that means is we can change the amount of samples we actually need to render to 1. So if I come over to the render settings and I look at max samples, I'll just change that to 1. And I'll also turn off noise threshold. And no, I won't turn off noise threshold. I'll turn off denoise. Now if I render this single image, render image, it's done. But it looks exactly the same. So the trick of rendering just world settings with Blender in the panoramic view is to set your samples to 1. And what we're going to do is just make some abstractions that we can then test in a 3-dimensional space. And then we'll book some time in the planetarium and watch our animations over there. And if we want to make more and do something more immersive, if you want to do your senior show in the planetarium, that's something that can be arranged. So that would be kind of cool. All right. Now, after I've plugged this together and I'm using cycles, there's some critical things I need to change. Because what we need to do when we render for the planetarium or for a VR headset or any of that experience, and people want this kind of stuff, you can upload fully 360-degree video, stereoscopic if you really want to, and you can upload that to YouTube. And all these nerds with VR headsets are going onto YouTube and looking for 3D and immersive content to watch. And so you can make money doing this kind of stuff from making that kind of content. So let's just make some trippy stuff, because people, you know, they might want to be kind of tripping out and having some trippy content. There's not a lot of it up there right now. Why are you smiling, Ariana?
Because like this is like such a typical thing. Like people just high on terms like in a VR headset, like freaking out.
I'm just making this up. I didn't know people do that.
No, but it's like such a like funny thing to like imagine like in my head. Like,
Okay.
I'm thinking about something like being on terms of just like right now.
Yeah, they go out to the desert or they go into their closet with a VR headset, and we're going to help them trip. All right? So in order to get there, we have to select the camera, and we have to change the camera settings. So with the camera selected, and we're looking through the camera now, I'm going to go over to the camera data right here. And right now, its type of lens is perspective. We will change that to panoramic. Right away, you see something change with the way we're rendering the world. And what you'll see is that the field of view is 180 degrees. So it's 180 degrees, meaning it's like a full dome in front of the camera that we're seeing, that it's recording. Kind of like a GoPro. But you'll see that this box around it is not quite what we want. And so it would render this rectangle, and it's a kind of a cool effect, but that's not really what we're trying to go for. And to give you an idea of what we would see, let's go ahead and just create a mesh. Let's go ahead and add the monkey right there in front of the camera. So the monkey's in there. And if we look through the camera now, the monkey's there, but it's not quite right. You see how the monkey's like really small, but it looks like it's really big in the outline. And that's because the 3D viewport can't really show the distortion of the panorama, but cycles can. So I'm going to split this view, and we'll just come out here, and as I move the camera, I'll turn off overlays. As I move the monkey closer to the camera, if I hit G, you'll start to see those distortions as it gets close to the edge. You see the distortion? So to us on a flat screen, it looks really distorted. But if this were projected on a dome in a planetarium, then that distortion would just look like the monkey is on the wall to our right. Okay? And if I put the monkey about, let's move it around here. If I put the monkey about right here, and then a little bit further from the camera, G, to about right here, to about right there. Right there. That would be, that area right there would be if we were sitting in the planetarium and we were looking straight ahead. Then that area would be where we were looking in front of us. And this is a really hard thing for my students, all my students and myself, to wrap our heads around. When you're designing media for content that's not on a flat two-dimensional screen, you have to imagine what it's going to be like to see it. And so the closest we can get to that without going to the planetarium is with a VR headset, but we have to render it first to see it, and then we have to play it through a player in like the MetaQuest player system. And so all of this can be done open source, except for the playing of it, which is owned by Facebook. Yeah.
Will the center of it be like straight above you?
To be directly above us, it would be exactly, it would be right there on top. But the front of the planetarium is roughly about right here. So the next important step is to change our render settings. So we've changed the camera settings, but we have to change the render settings. And so the render settings the planetarium uses two 4K projectors to wrap video around us in that scene. And it uses, essentially it needs square video. So what we're going to do is we're going to change our render output to 4096 pixels. You'll also see that it's not quite reaching the edges of the frame now. So we just need to adjust the lens on the camera to make it do so. So if we just adjust the lens till it touches the edge, then we can be very confident that these edges represent the horizontal plane that'll be around us in the planetarium. Okay? It's confusing. That's why I'm talking about it at length, because a lot of people get it wrong. And when I've had students do this in the past, they keep putting Suzanne or whatever character they have here, they keep putting the monkey in the center of the screen because they're looking at it on their screen. And throughout their whole life, they've been taught, you put the stuff in the center, right? But what you have to see is that when it's in the planetarium and people are looking straight forward, this is the front and center of the planetarium. Why? Because we wrap this in a dome around us.
Oh, and you're looking, yeah.
So perhaps a better place to explain this is if we go to my website. I've got a system for doing this. And so this is like my Aurora shader that I sell on Gumroad and the marketplace. And so when I render this animation, it just looks like this on a two-dimensional screen. But when it's wrapped around the planetarium, and you look around, then it looks like this. So this is what it looks like in the VR headset, and this is what it looks like in the planetarium. But you can see here, you see that text right there that says Buffalo State. That's right there in the center of the screen. But look at it in this projection. I know the projector isn't very bright, but you see how it's squished down here at the bottom? But in the planetarium and in the VR headset, it's straight and looking forward. You see that difference? Had I not shown that to you, would that make any sense?
How do you figure that out?
I am smart. It's fairly straightforward. But there is a dearth of content for planetariums and for this kind of material. And so there's a growing need for it. And so if you have this kind of work in your portfolio, you can create immersive media. It's necessary for not just planetariums. If you go to any museum, they're having all these immersive, interactive environments now. They need this kind of content.
The Vegas Dome.
What's that?
The Vegas Dome.
The Vegas Dome. My former student, Dylan, has a contract right now where he's producing a whole bunch of content for the Vegas sphere.
This kid Dylan is really.
He's pretty cool, yeah. Keep asking him to teach a class here. But all my students that really got into this, they all have good jobs, so it's good. I'm not bragging, I'm bragging. Okay. So, having known that, let's make a strange abstraction that we can then test and then render out and then test it out on the VR headset. And then you guys can all like share it and we can all spread germs or something. I'm going to get rid of this monkey. And I'm just going to use shader techniques to do this. So that way it renders quickly and we can do a test. I'm not going to try to make a tunnel that we're flying through, but you're welcome to try any of that if you want. So instead of a noise texture, I think what I'm going to use is, let's use a texture, let's use a wave texture. And so if we plug the wave texture in, we see the wave texture here. And this will be kind of trippy, but it'll be fun. And then I'm going to use node wranglers to arrange the center of this procedural texture into the center of my 3D viewport. So I just need to change the location of it here, or the rotation of it, what's going to rotate it around here. Nothing, there we go. So I'm just moving it around. So that's going to be roughly the center of my field of view in the planetarium.
And that's where when people are looking straight instead of like.
Exactly. It hurts their head to look straight up. But they'll have content that'll be behind them, and that's the weird part. I think a planetarium shouldn't be sitting. I think it should be standing. And I think people will be doing this in concerts and so forth, in Las Vegas, anywhere people are trying to keep people there and keep them entertained, right? And possibly advertise to them as well. So yeah, it'll probably be advertisements. It won't just be for tripping people. So anyway, so I've got this circle, the center of these concentric waves here in the center. I can use that now to separate between different colors. So if I wanted to add a color ramp, I'll plug that into this view. And so you can see if I move that color ramp around how things change, but I can also just make that color. So let's go ahead and just add like a red. Let's go ahead and add like a green. And let's go ahead and add a yellow. This will be intense. And instead of being gradients, you could just have it be constant, and then you would have a constant color. And you can move these around. Now keep in mind, if you're in Eevee, it'll just look like this. Okay? So that's why it's necessary that we do this in cycles. So that way it renders properly. Now to see what that is actually going to, how long a 4096 by 4096 animation like this is going to take to render, let's go ahead and save our project, save as, and we'll call it, let's go to Documents, New Folder, Immersive 1. And we'll call it Immersive 1. Save. So let's render one frame of this and see how long that'll take. And this is on a very weak computer. And you can see it's a little bit noisy, but that might just be the gradient that I have on there. It took 2 seconds to render. So even though it's 4K by 4K, when we render in this method, it's fast. And so that can help us iterate and make things very quickly. And so I don't know why that noise is there. We might have to do some tricks to get rid of that. But oh, it's because there's one little edge right there. That's why there was little things in there. Okay. All right. So now if I want to move that or just create a simple animation, let's just go and we can move. I've got to find which axis it's moving on. It's not that one. There we go. It's kind of hard to see, and that can sometimes get in your way of what's actually happening. But if I move this on this axis right here, it's basically creating like a puddly sort of shape here where everything's moving. I can also like distort things up and make things kind of wild. I can add detail. I can change the scale. I can make this more detailed, or I can make it less detailed here. I think I like something like this. And so what I want to do is, now that I know it's the x-axis that I can animate on, it's kind of hard to see which direction it's going. I'm going to open up a timeline here. Let's open up a timeline. I'll set a keyframe for the x-axis here. I'll just move it back to 0, and I'll type in I. Then I'll go to frame 250, and I'll just move this guy over. And then I'll hit I again. So I've created 2 keyframes. We don't see keyframes here unless we actually select the node. Then we see the keyframes. And then if I move back over here, I can try to play it. The problem is it's cycles, so it won't play very quickly. And I don't know if it's actually moving in the way that I was hoping, where it would be moving in a way that I see like lines flowing around us. If that's not the case, then I got to find a different way to do that. We could try changing like the type of vectors here, or we could change this to object. Sometimes things like that will do the trick. But really the only way, turn off that, the only way to know for sure if we're getting the look that we're going for is to animate it, or to render the animation. And if you're trying to test the animation, you're trying to render it in a way just to test it, there's no reason to render it at full 100% 4096 by 4096. So what I'm saying is, let's just do a quick 20% render to see what this is going to look like this. And to see that as a video file, we'll choose FFmpeg. We'll give it a destination. We'll go to our documents that we were just in, not on our OneDrive, but here. We'll call this test render. And so we're going to be rendering at 24 frames per second. We're doing a FFmpeg, but let's make sure it's an H.264 and an MP4. and then we'll render that. Now, our final renders will have to be as EXR files if we want high dynamic range. Supposedly, the planetarium can handle high dynamic range 16-bit images, and that lets us have the brights be brighter and the darks be darker. I've done some tests. It doesn't seem to make a big difference. But let's render these 250 frames out real quick. So we'll save that and render animation. So we're rendering with cycles. We're rendering at 20% of 4K, and we'll see what happens. And we're doing this on a pretty weak computer. So do we have anything? Oh, so it looks like it made it to frame 28. Maybe. I don't know. Let's try again. Render a save. Sometimes if it's moving so fast, it doesn't show you any feedback, so you don't know what it's doing exactly. Oh, okay, right here. It couldn't render it because it says the width is not divisible by 2.
What? What is it? What?
It is 4096. So normally it only does that if my division here is 40 is an odd number. But the reason it's doing that is this % right here is causing that to be slightly off. H.264 can only render things with render resolutions of even numbers. So let's just try changing this to 21%. There we go. Hack the system. Every time I've encountered a problem, I've learned how to overcome that problem. So it's rendering. It's on frame 16, 17, 18. Well, some of the things coming out in Blender's new versions, if you download 4.4.1, is they're getting much better at explaining errors to you, why things aren't working the way they're doing. That's one of the biggest complaints people have had about Blender for a while, is that they don't know why it's behaving the way it's doing. So if you look at the bottom of the screen, it'll explain to you why things might not be working in the way you expected, or it'll send out warnings about scales being uneven and so forth. Aiden, you have a question? Well, Sheepit will often block projects if it sees that it's rendered with cycles and it's a 4096 by 4096 resolution. It'll think it's too heavy. So the way you get around that is you render things like this, where it renders very quickly. And then the way Sheepit works, if it says this project is too heavy, it's going to be blocked, but it won't be blocked by us. So one of our computers will render it, and then Sheepit will say, oh, it's not that heavy as we thought. Because it's just looking at those numbers, 4096, 4096 cycles. It's going to take hours per frame to render, so that's why it'll block it. But once one of our computers renders it, and it only takes a minute or two, then it'll send it to the rest of the farm. It's just a protection service, because sometimes people send up projects to the farm that crash everybody's computers. And they're just trying to prevent that from happening. So you can see I'm already at frame 150. So it's almost there, but that's 20%. So if we did this at full 100%, it'll still take a few minutes, but it won't take that long. Tyler.
So when Sheepit says like to render your own frame to test and see if it will pass that, what do we do? Does that just do that automatically through the ones that are registered on there, or do we do that ourselves?
When it says, but you can render it, what it's meaning is our farm, because we're all using the same Sheepit account.
Yeah.
So what it means is one of the computers that I might have in here, I've got a computer in my office that's always rendering for Sheepit. That's why it's so hot in there. And so it'll just send it to that computer. If that computer can render it, then it'll send it to the rest of the farm.
Yeah, that's what was confusing me, because like I was trying to figure out how I would go about doing it on my personal computer.
Yeah.
And I'm seeing that message back.
No, it'll send it to all these computers, and it just won't send it out to the farm. So you can use, and you can select to do that in Sheepit that only render with your farm, but these computers are not fast, so I don't recommend it. I sometimes use the computers next door, and I have those plugged in, but they keep going in there and restarting the machines, and so I can't. They know what I'm doing, yeah. They know what I'm doing. Actually, IT the other day changed the policies on all these machines so that even if you were rendering or you were logged in and doing something, they would log you out. And I said, you didn't ask me. And our students do more than write Microsoft Word documents. They're rendering, and you're canceling their projects. And they said, we're sorry, we'll turn it back. And so now they have, but they throw in policies like that all the time. And I stop it. All right, so I've rendered an MP4 here. It's only 3 megabytes, and I don't think it's going to have the look that I was going for, but I'll figure it out.
Oh.
There we go.
Yeah,
So,
that's good. We should go into planetarium and watch it, right?
so I think it didn't look like the way I wanted because it's really fast, right? So let's slow that down. So one way I can slow it down is just to spread out these keyframes really far. Jafar, all right? So I'll just select this keyframe and just move it way down over here. So I've 20,000 frames. It's probably overkill, but you get the idea. So one of the things that we can do after, oh, barely moves then. Oh, all right. And it's also set to be easing, so let's set the keyframing to linear. So we should get some basic movement now. Yeah, there we go. So after you get like different abstract animations and you get them rendered at full res, you can take them into a program such as Premiere and DaVinci, and then you can edit a show out of that. You just have to set up a timeline that's 4096 by 4096. The computers don't know that the animation and everything is meant to be in an immersive environment. It's only when you upload it to YouTube that you have a little selection, is this VR? And you turn that on. Then it will actually be that way. And if you encode with the media encoder, there's a little selection to do that too. I think if you're doing it completely with open source, there's a little hack we have to do. Anyway, so let's render that animation one more time. And again, we're rendering this just at 20%, just so we can see it. And I'm rendering it as an MP4, but when I would render this for final output, I would use OpenEXR or something along that line. And I'll just render 100 frames this time because we know it's working.
And so, like, even when something looks like squished by the edge of it, when that goes onto there, it will find, like...
In the planetarium, it should just look like concentric circles, like a tunnel coming at us. And when we look behind us, we see the circles collapsing. Well, not quite, because we don't have that in the frame. But you have to imagine this is a 180-degree sphere wrapped around us. After this renders, I'll show you one way in Blender we can actually see that.
Dislike that color combo. I don't like it. It looks like curves the Charlie when his eyes get all bugged out.
It's our new school colors. It's the low-budget school colors because yeah, it's just the orange is too expensive, so we have to have this puke yellow and green. We're getting all these emails that like OTPS budgets are cut and everything, and like, wow, we had to change the school colors. The orange is too expensive. And the people would be like, what?
They'll be like, why is the big one?
I don't like orange and black anyways. Like, it's always Halloween.
I agree too.
I think a bigger frame is a stupid animal for the
You really like
I think it should be a water buffalo, or if you were in my previous class, the worm.
You could spend like millions of dollars and kind of like a worm train go around the entire campus.
And when we play against rivals in sports, we just bring a whole box of worms and we throw it at them. Like, if you is that animal abuse if you like throw worms and stuff? Do people care about earthworms? I don't know.
I mean,
You ball it up like a snowball and you say worm fight.
Put worms down people's shirts. Ah! Render talks. All right, I'm going to save this. I can't say I have since I was 10. No. Have you ever tortured a kitten? All right, so. All right, look up here. Look up here. I want to see what that. I don't have a VR headset yet, so I want to see what that projection looks like in a half dome. Here's how I do it. I'm going to add a sphere, a UV sphere. Then I'm going to look at that from the side. Then I'm going to look at it through X-ray mode. Then I'm going to go into edit mode. Then I'm going to cut that bad boy in half. X, delete those vertices. So I cut the. Now I've got a planetarium, right? I'm going to write shade smooth. Yeah, I'm going to just add a movie texture to it. But in order to do that, I have to view it from the bottom. So I'm looking straight up at it, okay? And we have to unwrap it so that it fits, okay? And the way to unwrap it, since we're trying to project onto it, and it's not quite right because the edges here are a little too steep and the planetarium is a little bit more round, but it's close enough. So what I want to do is first put that image texture onto it. So I'll give it a new texture, and I'll add the texture. And we'll just use it as an image texture or a movie texture. So we'll open it, and it should be in Immersive 1. There it is. And when you add a video file, for whatever reasons, it defaults to 1 frame long, and the only way to make it see more is to open up this side panel and hit refresh. Now it sees all 250 frames. You're welcome. All right, and so then if I plug this up, not to the base color, but to the emission color, and turn up the emission to 1, and then also change the, plug it up to the base color as well, turn up roughness all the way. There we go, it's perfect. No, I haven't unwrapped it yet. That's why it doesn't. I haven't unwrapped it yet. So we got to unwrap it so it knows how to wrap this texture around it. By default, textures are always put on objects with a UV map. But the UV map was for a sphere. I cut the sphere in half. So looking at it from viewpoint, the bottom, and it's important to look at it from that direction. Let's go over to the UV editing tab actually. And then this one here, we'll go say viewpoint bottom. So we're looking at it from the bottom, and if we want to see what we're doing here, look at that texture, and we can load that texture here so we can see how it's actually wrapping around it. If I hit A, you can see the UV sphere is wrapped around it like this by default. That's why it looks like this. If I move that around, G, it's like, so what we do is we project from this view. So we go to UV, and we unwrap, and we project from view. Where is it? Yes. Project from view, and we use bounds. So now you see it's wrapped around that from that direction right there. Okay? And so then if we go back into layout or object or shading, and we look at our map, you can see it's kind of stretched around the sides, but we can adjust that a little bit. But overall though, and let's turn on auto refresh. If we hit play, we'll see our animation moving and how it would look in that planetarium. With a little bit, it does distort at the bottom a little bit, and if we want to tweak that, we can just take these UVs and scale them out a little bit or push them in a little bit. And that might clear it up. Layout. Shading. There we go. So depending on what we're doing, I don't think we'll have that level of distortion, and it would look a lot clearer when we do the full render. The reason it looks so aliased is because it is rendered at 20%. And so at full resolution, we would see the whole thing. And then Blender can show you the whole video as it would look in the planetarium, which is kind of cool, right? So half dome, cut it in half, unwrap it, project from view. That'll do the trick. But when we want to actually play it in the planetarium or in the VR headset, we can just take this straight video and play it that way. Okay, so what I'm going to do is I'm going to render it out at full res, and then get it on my PC over here, and then I'll get out the VR headset, which I've been charging this time, and then we'll test it that way. Okay, so the reason why I'm doing this with the shader nodes in this way is it allows us to quickly test and do things like with this, so that way we can see what our renders are actually going to look like. Does that make sense? So if you wanted to render a complex 3D model, a tunnel, spaceships, and all that, you can do that. But it's good to do it this way first, so you get an idea of what it's like to work in this disconnected mode. So when we're working on that tiny computer screens that we have, for a large 24-inch poster, we have to do some mental translating in our heads, right? And I noticed a lot of you in Premiere and After Effects, because we're looking at a little screen on the monitor, make your text too big. So we always have to imagine what our production is going to look like in its final state while we work on it. And so if we go through a couple practice modes, then we'll get a better idea of what it feels like to work on the tiny screen in production mode for the big screen in the final output. That helps us get our text size proper. That helps us get other things. And I also have one of the videos that they show in the planetarium to give you an idea of what it looks like flat on the two-dimensional screen for the planetarium screen. So I'll pull that up here in a minute.